Alright, so let's have a continuation about how are energy and work related. So are they really the same or they have different functions? So when it comes to work and energy, no? In our literal understanding, in order to work, to do and perform work, in order to accomplish our task, we need to have energy. That is why in our literal understanding, energy is ability to do work. If we don't have enough energy, our work might not 100% or fully accomplish because of less energy once we're going to perform those things or tasks. Now the big question there, how are energy and work related to each other? And remember that work is a certain task. It's part of our responsibility to do. Just like what you did right now. You're not entitled as a worker or working something, but as a student, no? You have responsibility to do. How you work it out, how you complete those things within that period of time. Remember your work. No? Being a student, okay, you have designated tasks to do. Many subjects, various subject areas to focus on, to concentrate in order to complete your task given from your teachers. So the word work, it is the transfer of energy that occurs since you understand your responsibility. No? When a force, your strength, you know your strength, you know your weakness, that you can work it out. You can perform well. If you know your potential, you know your energy, that this is the only work that I can do. Yes, I can do. You can create something big from the small thing that you have started. Okay? Look at yourselves right now. Okay, you were able to make it. Since when you were infant, then you reached to Buliban, Anuban, then to grade school, then now high school. Okay? Time keeps changing. As years gone by, you were able to experience those various learning areas in your life until this moment of time. So when your force makes an object move in the direction of the force while the force acts on its object. Okay, literal examples. Bringing your bag to school. Carrying your bag, heavy bag. You have your computer, your gadgets, your notebook, your books, okay, including your lunch bags, okay, your drinking water as well. So you're carrying those things from home going to school. So it's also part of work. You might even feel the weight of your bag, either it is light or heavy. It's also part of your work. Okay? Going to different rooms when you attended, okay, your classes from time to time. So it acts out based on from one place to another place or a direction, either near or far. Still, the force of your legs and your foot, okay, work on it in order to keep transferring from one place to another place. Okay? From this building going to the cafeteria or attending your classes from this building to another building. Still, you are working. So there is a presence of work. So first acts on your strength. Okay? Based on your potential, your capability to do this work. Either it might be hard for you or maybe easy for you. So it also depends on your decision. Okay? Studying is hard for you since that is a work. So students should work hard in order to accomplish what he or she is looking forward. Because that is the system. We need to comply the work, a certain task, in order to level up your learning experience from time to time. And that's how it works. So in this case, we set some examples like this, your potential energy, the presence of kinetic energy, how to comply that this is a certain work, it must be potential energy is present. Now the question there, do you have potential? Yes? Each of you has a potential to do and perform the work well. It depends on your strength. Depends on the level of energy that you can perform in that period of time. Your potential to sing, to dance, to play sports, it's part of work. It's not like very heavy tasks, just like what your parents are doing right now. They are working in different fields, in different offices, or various occupations, different businesses. It's a different thing. Just like the workload of teachers, it's a different thing. But in your case, as a student, your work still on the basic and advanced level of learning, because you are training yourselves, okay, how to adapt or embrace the real life in the future. So you have light work to do based on your academics performance. So you have potential energy to do work with your academics, studying different subjects. Either you are very good in that or you are just average in that subject. Still, work is present. Okay? And of course, when can we say that the kinetic energy is present? So, as I've said, factors that affect are potential energy and kinetic energy. So, the kinetic energy, this is the moment of working. Changing from one place to another place, or by transferring the objects or workloads from one place to another place. Okay? Especially studying, working hard, making projects, assignments or homework. It is part, that is work-related situations of you guys. Okay? So, work helps us to transfer no? Our energy that usually occurs in that period of time in which the level of force and our strength, okay, must be present. When it comes to our potential energy, kinetic energy, that's how it works out. Okay? So when we say work is the transfer of energy that occurs when force makes an object move in the direction of the force while the force acts on an object. So for example, in sports, golfer does work on clubs. Okay? The golfer does work on ball. So what should be the energy in a golfer? So the energy in a golfer, okay, converted into energy in a club by hitting the golf ball. Then after that, energy in the ball appears. Okay? And it will transfer to another place. Once it is being hit, okay, by the energy in which the golfer does work on a club. So forces are pushes or pulling. The ball, if you remember, we refer to the third Newton's law of motion. In every action, there is always an opposite or equal reaction. The student does work on the box when he lifts it. Once the box is in place, no work is being done. So, when we lift an object up, we can feel also that the box is heavy or it might be light. But still, the reaction of your body, by picking up the heavy box, and then your body also have a reaction to that certain object by moving upward. Okay? So the weight of an object state is based on gravitational force or gravitational weight. Once you lift up, there is an upward force. Okay? That is being created by you. Okay, coming from the strength of your arms, so that you were able to lift up that object. So the student does work on the box as he lifts it. The box kinetic energy and gravitational potential energy also increases. So the student is longer doing work on the box because the box is not moving in a direction of the applied force. So, how does energy and work related? If you do work on an object, how it will energy change? Doing work on an object changes its energy because the energy is transferred from the force acting on an object. To do work on an object must move in a direction of the force. So say for example, the direction of the force moving on the right, then the object will move in the direction as a result of a force. If you remember about the resultant force, right? So it also affects the strength or the level of magnitude or force under the resultant force will also be a factor that the object will move. Okay? If the object is heavy, then the force is just only less. Okay? It might be that the object may move or will not move. So work is one only while the force is moving the object. Work also depends on the distance an object moves during the time, okay, where the force is being applied. So look at there, the work equation. So the unit of work, okay, is commonly known as joules. It's part of the unit of work, or joules. Then, work is equal to force, which is the unit is Newton. And, of course, directly proportional to distance, the unit is meter. So therefore, what is the formula? Work is equals to force times distance. Okay, that's what it is. Right? So the equation for work is shown below. According to the Newton's law of motion, be going back for this one, although it's been a long time we discussed this. Force, it is a force applied to the object. Distance is a factor in which the distance of an object moves in a specified direction of the force while the force is acting on it. Now say for example, considering by using the spring scale, the gravitational force moves downward due to its object's weight, or the gravitational weight. Okay? So this is literally how to determine which, according to the Newton's law of motion, it also affects where the force in this equation under the Newton's law, the distance, it should be in meters. Okay? The product of newtons and meter is in Newton meter. So that's why it's written with Nm. If you remember, the last time we discussed about moment or torque, we use Newton meter. So a Newton meter, it is a joule, or literally work. An object has mass, which is the total amount of material it is made of measured in kilograms. Mass is not a force. We measure forces in newtons using a force meter known as Newton meter. So the word Newton comes from Sir Isaac Newton, okay, who first put together the ideas about forces and the law of gravitational force, or the law of gravitation. So in this one, in mathematical skills, when we solve for a work, a student lifts a bag from the floor. His or her shoulder has 1.2 meters above the floor, using a force of 50 Newton. How much work does the student do on the bag? So, this is what we need to know first. What is given? Force is exactly 50 Newton. And the distance in this situation is 1.2 meters. So, that's what you need to find out. What is the acceleration or work? We need to use the formula. W stands for work equals to F times depth. For this one, so work is equals to force times the distance. So again, we need to do the substitution. Substitute the component. W, which is 50 Newton, times 10 Newton, okay, equals to 60 Newton meters. So therefore, we have 60 joules, right? So the value for F and D into the formula and multiply them. So therefore, the amount of work done is 60 joules, right? So energy and heat. Friction is a force between two forces in contact with each other. So we have what we call the force exerted. Okay, and the friction, for example, playing the layer of ice on the sledge. So the boy move in this direction. So the direction of friction in the opposite direction of its motion. So in every energy transformation and every energy transfer, some energy is transformed into thermal energy. So this thermal energy is transferred to the surroundings with high temperature, then further converted to low temperature. So the thermal energy moving from a region of higher temperature to a region of lower temperature is called heat. I'll repeat. So thermal or heat, it is an energy moving from a region of higher temperature to the region of lower temperature. So have you noticed, guys, by the time we are going to start lighting up the flame in our gas stove or LPG, then we put the pot or hot pot there. So it always starts where is that flame focused on, then further spread out to the lower concentration region of the hot pot, and then the heat will be even after a few minutes. Then it keeps reaching to the maximum heat temperature. So always remember how the heat is being transferred from higher temperature to low temperature of the surface of a hot plate or pot. So scientists sometimes call this one heat waste energy because it is not easily used to do any useful work. So to summarize, work and energy are related.